let's look at some graphs now with log expressions here. First one is state the transformations of f of x needed to form the graph. In fact, it should be f of x equals, equals log x to the base. I'll just do that down here. So we're looking at the transformations of the basic log graph, there we go, to form this one here. So let's look at, first of all, dilations, which we should always look at first, and we've got a 2 there. So first thing we're going to look at is we've got a dilation 2 units from the x-axis. We've got the -3 there, so that's going to be a horizontal translation, 3 units to the right. And finally, the +1. That gives us a vertical translation 1 unit up. Okay, next question. Sketch the graph of f of x equals log x plus 1 to the base e minus 2, marking the vertical asymptote and the intercepts. Alright. It's handy just to start with, just to draw a quick sketch of what this graph might look like. So, I'm just going to do just a quick set of axes. We've got our basic log graph here, which passes through 1. And what are we doing to this? Well, we're moving it 1 unit to the left. So we're going to get an asymptote. That's now going to be here, 1 unit to the left. And the new graph will pass through, because it's moved 1 unit to the right, like that. Okay, and then we've got it moving down 2 places. So it will actually pass through the intercept here at -2. Alright, so we've got this sort of situation there. So we're actually going to have an x and y intercept here, because remember, in the normal, if you look at the black graph there, we don't actually have a y-intercept, but we're going to have one here because the graph has been moved 1 place to the left. So I'll rub that out now, but it's always handy to know whether we're after, which intercepts we're after. We're after an x-intercept and a y-intercept, and we know the general shape what the graph is going to be. So let's get started finding those intercepts. Now we sort of already know that y1, but let's verify it. Excuse me. So to find y-intercept, we make x equals 0. So y equals log 1 to the base e plus 2. And sure enough, log 1 to the base e is 0. So we end up with 2. Y-intercept 0. Sorry, -2 that should be. Beg your pardon. So we get 0, -2. And we just suspected that. That's why it's good to draw that quick sketch to start with. X-intercept, we have to make y equals 0. So 0 equals log x plus 1 minus 2. Take the 2 across. 2 equals log e to the x plus 1. Now remember, if our x is trapped in a log, we get the exponential version. So e to the power of 2, equals x plus 1. X equals e to the power of 2 minus 1. Now if you work that out on your calculator, e to the power of 2 minus 1 is going to be 6.39. So the x-intercept is going to be 6.39. Alright, so we're ready to draw our graph. We've got our 2 intercepts. the x-intercept and the y-intercept. And we also know we've got a vertical asymptote at -1 because the graph was taken one place to the left. So let's draw all that in, shall we? Let's start with the vertical asymptote, which is about here, -1. We've got just remind myself, it was 6.39 here. Now, of course, we could just stick all this in the calculator, but I'm doing a lot of this because you may need to be showing working for these intercepts, so I'm presuming that you are. So it doesn't hurt to do that. So we've got -2 here as our other intercept. We know the general shape of a log graph. It goes like that, and then it starts going out in that direction. So there we are. There's our graph of, there it is, f of x, whoops, try that again, f of x equals that. There we go. Last example, more complex one, f of x equals 2 minus log 1 minus x to the base 3 log 1 minus x to the base e. So we've got a lot of things happening here. We've got a dilation. We've got 2 reflections there and there. And also we've got a shift as well. Alright, so let's have a look at all that. Well, let's draw, as we did last time, some rough axes to start with. Okay, so I'm just going to get a general feel for this graph. So here we go. And let's mark in the original graph like that. And a few things are going to happen to it. I'm actually going to concentrate first of all on the 2 reflections here, and also the asymptote. If you look here in my bracket, I've got 1 minus x, and sometimes we get confused. Now, where are we shifting that? A 1 minus x always shifts the graph one place to the right. Okay, and the theory being that what you've got in there, if 1 minus x is the same as -x minus 1, so the negative does our reflection for us, and the -1 moves it one place to the right, because mine is outside of x minus 1 is the same as 1 minus x. Right, so we've got our asymptote is actually going to be, might just make a different colour here, one place to the right, so I know that much. But I'm also going to undergo 2 reflections here. Okay, so the first reflection would take this graph and make it go the other way, like so. And then if I reflect that in the y-axis after that, because remember we've got 2 negatives to deal with here, it would now go over to here, like so. Okay, I haven't drawn that very well. So I might just do that resultant one, and we might just rub this one out as best we can. A bit hard without rubbing everything else out, but you get the idea. So our graph, after the 2, is going to be something like that. It's been shifted and undergone both reflections. So I'm probably going to get a y-intercept about there and x-intercept about there. Now I always like doing that rough sketch first, because it gives me an idea of where I'm going. Alright, so let's look at now finding the long way, the x and y intercept. We know where the asymptote is now. Alright, so here's our function. Y-intercept. Y-intercept, we make x equals 0. So y equals 2 minus log e, 1 to the base e, because 1 minus 0 is 1. So that's going to be y equals 2, because log 1 to the base e is 0. Okay, so back on our rough sketch, that y-intercept is 2, and that fits in with what we've got already. Okay, x-intercept might be a bit trickier. We make y equals 0. So y equals 2, no it doesn't, 0 equals 2 minus 3 log 1 minus x. Right, I don't like negatives, and I've got one right. Let me have a look here. That's better. I've got one right here, a -3. So what I'm going to do is actually going to take that -3 log expression over the other side. I've got my e there, by the way. Okay, that's made it positive, equals 2. Now I like that because don't want too many negatives. Alright, so divide through by 3. 2/3. Now liberate the x out of the log expression. Now I've got a -x, I want a positive x, so I'm going to stick the -x on the left and make it positive. Leave the 1 where it is, and we've got that there. 1 minus e to the power of 2/3. On the calculator, that's equivalent to -0.95. Okay, and that sort of fits in, if I go back to my rough sketch, that sort of fits in as well. That's why the rough sketch is good, because you can match up what you get for your intercepts with your rough sketch. Alright, so we can now draw it. Asymptote at +1, shifted one place to the right. Got our y-intercept at 2. Our x-intercept was -0.95, which is very close to 1. We know the general shape of the graph, so it's going to end up being something like this. There we go. There's the graph of the function. Domain and range for this graph. The range will be real values. Okay, the ranges are domain. Okay, we're only on this side of that asymptote, so it's going to be -∞ to 1, curvy brackets. Alright, that gives you now an opportunity to do exercise 4D. Have fun.